Supply chains are complex environments. When performance suddenly drops, the true root cause rarely announces itself. Instead, it hides behind layers of overlapping symptoms and conflicting data. To cut through that noise, strategy consultants use a specific diagnostic framework called an issue tree. It takes a massive, unstructured problem and breaks it down into manageable, solvable parts. By systematically mapping out every possible angle, the tree ensures teams don't suffer from analytical blind spots. It provides a clear, step-by-step roadmap for the investigation. Before anyone opens a spreadsheet or pulls historical data, the problem has to be structured. If you skip this step, you risk spending months solving the wrong problem entirely. Formally, an issue tree is a structured, hierarchical decomposition of a complex problem. For that decomposition to be valid, it must follow a strict rule. The branches must be mutually exclusive and collectively exhaustive. This is known as the MECE Principle. MECE ensures that different categories do not overlap and that the entire problem space is covered. Because of this rule, the tool is strictly hypothesis-driven. Instead of just listing observable symptoms or past data points, it forces you to map out the underlying structural drivers that could be causing the issue. This logic ensures the tree functions as a rigorous diagnostic framework, separating professional problem-solving from simple brainstorming. Imagine a company experiences a severe drop in OTIF. OTIF stands for On Time in Full, and it is a key metric measuring how often customers receive their exact orders exactly when promised. We start by taking that main problem and branching it into 3 broad issue buckets: demand-related factors, supply-related factors, and internal operations. Next, we take the demand branch and break it down further into specific testable drivers, like forecast accuracy and demand volatility. The rest of the tree follows suit. Supply breaks into supplier reliability and capacity constraints, while internal operations splits into planning processes and logistics. This framework maps out every potential driver of that underperformance. These terminal nodes translate directly into actionable KPI diagnostics that can be assigned to specific teams for review. This diagram shows a classic profitability issue tree. At the very head of the structure, we anchor our primary problem statement: why isn't our company profitable? From that anchor, every tier moving to the right must definitively answer a single question: why, or what drives this? Here, profit drops because either revenues are too low or costs are too high. By continuously asking why, the investigator is forced to step down from macro categories to highly granular root causes, like noting that the number of new clients is simply too small. The architecture of the tree dictates the path of the investigation. If the logic fails at those early macro levels, the granular root causes will be misaligned with reality. To maintain mutually exclusive branches, every part of the tree must be totally distinct. There can be zero conceptual overlap or double counting between your categories. To be collectively exhaustive, those distinct branches must combine to cover 100% of the possible problem space, leaving absolutely no gaps in logic. This logic-based architecture differs from other common tools. A fishbone diagram, for example, is built bottom-up to trace cause and effect relationships, whereas the tree applies top-down diagnostic logic. It also differs from mind maps. Mind maps are designed for rapid, non-MECE idea generation. They are intentionally free-flowing and lack the rigid boundaries required for structured problem-solving. Adhering to MECE creates a defensible, mathematically sound diagnosis rather than an incomplete guess. Because of that rigor, this tool is used for consulting strategy, KPI gap diagnosis, and executive scenario planning. But building a functional tree takes discipline. A common error is populating branches with observable symptoms, like a rate shipment, instead of the underlying structural causes driving that delay. Another trap is creating overlapping branches. When categories are not mutually exclusive, teams double count data and waste effort investigating the same variables twice. Analysts also tend to rush into the details. Mapping out hyper-granular points before proving that the macro categories are sound will quickly derail the investigation. Treating this framework as just a passive data chart rather than an active tool to force logical thinking leads to analytical paralysis. Ultimately, the issue tree forces rigorous thinking before any data analysis occurs. The framework's job is to structure the correct questions. It does not automatically provide the answers. The quality of strategic decisions is directly tied to the MECE quality of the underlying tree. Mastering the ability to decompose a problem logically is a mandatory skill for operational leadership.